Today we are naming covalent compounds. So to read the direction, these are formed when nonmetals or from nonmetals that share electrons. Because there are many sharing possibilities between two nonmetals, the formula cannot be guessed unless we have a naming system that reveals the number of atoms involved. Basically, in order to name covalent compounds, you need to be specific in the number of atoms. So we're going to use this prefix chart to help us out. Mono means 1, di means 2, tri means 3, tetra means 4, penta means 5, and hexa means 6. So some examples are CO has 1 carbon and 1 oxygen. If you look down here, we are not going to put mono in front of the element or the atom if there's only one at the beginning. So here you only have 1 carbon. We're just going to write carbon instead of monocarbon. But with the oxygen, because it's the second element, we are going to put mono in front of the oxygen. Remember the rules that your first element is going to stay normal, and then the second one we are going to add IDE to the end. So CO is carbon monoxide, CO2 is carbon dioxide, N2O5 is going to be dinitrogen pentoxide, and PCl3 is going to be phosphorus trichloride. All right. So in this first table, they give you the name, and you are going to write the formula based on the name that they give you. So this first one is nitrogen trifluoride. So there is nothing in front of it, so that means there's only 1 nitrogen. Fluoride here, and then it says trifluoride, and based on our table, that means 3. So that is our formula for nitrogen trifluoride. Let's try nitrogen monoxide. Nitrogen, you've got mono, which means 1, so just 1 oxygen. Okay, let's try another one that is not nitrogen, or a mononitrogen. So dinitrogen tetroxide. Di means 2, so there are going to be 2 nitrogens. We're going to write these as subscripts. And then tetra is going to be 4, so O4. Okay, let's try a different one. So we have phosphorus trichloride. Phosphorus is P, chloride is Cl, and there's 3 of them, so 3. Let's try sulfur hexafluoride. Sulfur is S. There's no prefix there, so we don't got to worry about it. And then fluoride is F, and hexa is going to be 6. We have disulfur, so 2. Decafluoride. So we didn't talk about deca, but deca equals 10, okay? So we have 2 sulfur, we know it's going to be fluoride, and then deca means 10, okay? Fill out the rest for your practice, and then this is going to be the opposite, where you are writing, or they give you the formula and you're going to write the name. So we're only going to do a few of these. So CCl4 is going to be carbon. We have 4 chlorine, so it's going to be tetrachloride. I have really big handwriting, I'm so sorry. Okay, let's do another one. We have P4O10. So we have 4 is going to be tetra, so this one's also going to be super long. Tetra phosphorus. Oh my goodness, this is so long. Tetraphosphorus decaoxide. Okay. So super long, but this one, these 2 are together and they go for this column. Okay. Let's try another one. So we have sulfur. I'm just skipping around at this point so we get to see a little bit of everything. And then we have 4 fluorine, so tetrafluoride. Okay, so try the other ones, but you want to make sure that you are using this prefix box to help you with the writing. Okay. This side is very similar to what we did yesterday. So for picture, you are drawing the Lewis structure. And then for molecular formula, you are writing the formula. And let's do some practice also writing it out. Okay. So we have carbon and chlorine. So in yesterday's assignment, we practiced drawing the structure based on the chemical formula. We don't have the chemical formula, so it is our job to figure it out. So I'm just gonna kind of write all over the place, and then I'll adjust as needed. So carbon has 4 valence electrons, chlorine has 7. I'm gonna just draw the picture for myself because I'm a visual person. And then chlorine is 1, 2, 3, 4, 5, 6, 7. Okay? So for the picture, I'm always go with the idea of putting the atom that has the most open valence electrons in the middle. So carbon has 4 open spots, chlorine only has 1. So carbon's going to be in the center, C. 1, 2, 3, 4. And chlorine is only missing 1 spot. So I'm going to just tack on chlorine right here. 1, 2, 3, 4, 5, 6. This is our 7. And then connecting it to this carbon is going to make it 8. So we have 8 chlorines, 8 electrons in this chlorine atom, so it's good to go. You need to figure out then what else you can add to finish this off. Since chlorine only needed 1, you're going to do the same thing. So Cl, 1, 2, 3, 4, 5, 6. This is 7, and this is 8. Thank you. Okay, and then you're just going to keep adding it. Cl, 1, 2, 3, 4, 5, 6, 7, 8. Cl again, 1, 2, 3, 4, 5, 6. This is 7, this is 8, and we're connecting them. And the reason I only used chlorine is because those are the only elements that they gave you. Okay? If they gave you more elements, then you can obviously get creative and, add them as needed. But they only gave us these 2 elements, so those are the 2 elements that I'm working with. So our molecular formula is we have 1 carbon, so it's going to be C. Then we have 4 chlorine, so I'm going to put C, Cl, and then 4. Our name is going to be carbon. And 4, remember we said, is tetrachloride. Okay. I'm going to do phosphorus and bromine just so I can give myself a little bit more space. So phosphorus has, where is my periodic table? Let's see. One second. I have no idea where I put it. Okay, so phosphorus has 5. And bromine has 7. Okay, so my Lewis structure for phosphorus is going to be P, 1, 2, 3, 4, 5. And then for bromine, which is Br, it's going to be 7. So 1, 2, 3, 4, 5, 6, 7. Okay? So phosphorus has more open spots in the center, or for electrons to take, so I'm just going to add it to my center. And then bromine is 7, so it's only missing 1 valence electron. Well, it's kind of perfect because I can just circulate, fill in bromine in all these open electron spots. So that's exactly what I'm going to do. I'm taking Br, and I'm just going to fill it up. There you go. Do it on the other side. 1, this is going to be 2, 3, 4, 5, 6, 7, 8. And then do it on this side. 1, 2, 3, 4, 5, 6, 7, 8. Bromine has 8, this one has 8, this one has 8, and then let's count out phosphorus. 1, 2, 3, 4, 5, 6, 7, 8. That one checks out too. So when I'm writing this one, it's going to be phosphorus, you have 3 bromine, so it's going to be bromide. And our formula is going to be PBr3. Okay? Hopefully this helped. Try the other ones on your own. I'm going to post an answer sheet and just make sure to check your answers. Please let me know if you have any questions.